So the question here says, show sine theta, cos theta, and tan theta to be equals to 45 degrees, 90 degrees. Okay. So for this question number 5, to do this, what I just need to do is to say, let this simply mean 45 degrees angle. Let the angle here be 45 degrees. This is 90 degrees, you know that. Notice that this side, when it's 45 degrees angle, and this side always look equal. So this and this are equal. So call this 1. Call this 1. You can call it 2. Call it 2. Also, so far as whatever number you are giving here and whatever number you are giving here is equal, no problem. But I'm using 1 for unity. This triangle, everything times 1 is still this triangle. That is why I'm using this 1, 1. If I have this to be the case, if I want to now use hypotenuse, since I know this side, I don't know the hypotenuse. Using Pythagoras theorem, any 3 questions you are doing and you are not thinking of Pythagoras theorem, how to do it, convert or use it to find the standard identities or double identities, you might be having issues. So I'll now say h square, hypotenuse square, is equals to x square plus y square. So I don't know the hypotenuse square. So this is going to be 1 square plus 1 square, x side y square. So this is going to be 1 plus 1, 2. So hypotenuse here is going to be, this square now moving over is going to be root 2. So equals to root 2. So if I want to now get sine 45, so sine 45 degrees will be equals to, sine means opposite over hypo. So opposite is 1. Sorry, opposite, yes, opposite 1 all over hypotenuse, which is root 2. But you know that root does not stay at the denominator. Is an abomination for salt to be at the denominator. So I do times root 2 over root 2. This will give me equals to root 2. Root times root is, this is going to be root 4, and root 4 is 2 all over 2. So sine 45 is root 2 over 2. Now what of cos 45? Cos 45 is, cos means adjacent over hypotenuse. So this is going to be, adjacent here is 1 over hypotenuse root 2 equals to, okay, times it so that you get times root 2 over root 2, which is the same thing as saying root 2 over 2. So why the tan 45 degrees will simply be the same thing as saying just numerator sine over numerator cos, or you say sine over cos, sine theta over cos theta. But me, I normally ignore the denominator. So this is going to be the same thing as saying just carry root 2 all over root 2. Numerator sine, numerator cos. So this is going to give you 1. But if you want to do it by mathematics so that I don't confuse you, let's do root 2 over 2 divided by root 2 over 2. You see that this is going to be the same thing as saying root 2 over 2 times 2 over root 2. This will cancel this will cancel this, which is equals to 1. I don't like doing this. When it's tan, don't stress yourself doing this, because if you are still doing this when it's tan, it simply means that you've not understood this course. To understand this course, it simply means that anytime you see sine and cos having values, just consider it that you are just looking at the numerator of sine divided by the numerator of cos, which is that thing I taught you in physics. Oh God, I've invented a lot, but it's well. So try and go through the physics videos I made on vectors too, where I taught you that there's a reason why you normally see, if I have this to be theta here, when the angle is made with the horizontal, and if I have this to be here, when the angle is made with the, let's say I have this, when the angle is made with the vertical. So notice that at this point, this side is facing this side, is it not? This angle is facing this, so this is the opposite. While this side is facing this side, this is the opposite. And remember that everything sine has to do with opposite over hypo, and everything cos has to do with adjacent over hypo. So since they have hypo in common, cancel this, cancel this. There's no business with the hypotenuse. So in this case, it simply means that with the one that is talking about opposite and the one that is talking about opposite. So in this case, notice that when the angle is made with the vertical, what you just have is that x-axis in this case will be sine theta for x-axis, because the opposite deals with sine. Sine is equals to opposite, y cos is equals to adjacent. So notice that when the angle is made with the vertical axis, you're having x to be opposite. While when the angle is made with the horizontal, you are having y-axis. This is y-axis to be the opposite. So sine theta here is equals to y-axis, because y-axis is the one carrying this opposite y-axis. This is the reason why in physics we normally say that that sine theta is equals to y-axis, because of this thing, because most of the angles you are considering is being made with the horizontal. But once you get to things like simple harmonic motion, where much of the angle is made with the vertical, you notice that you're always reversing it. The same thing with when you're doing inclined plane, you're always reversing it. Sin theta is now x and cos theta is now. So notice that if this is the case, notice that this side becomes this way, this one becomes the adjacent. So if this is the adjacent now, notice that this adjacent now is on the y-axis, is it not? And cos is the one that has to do with adjacent. So it means that cos theta is equals to y-axis in this case. And y here, this side is the adjacent, is it not true? This side is the adjacent here, and this is x-axis. So cos theta here is equals to x-axis. So this is how you derive all those things they normally tell you, where we normally say in physics, or y-axis means sine theta, x-axis means cos theta. If you don't understand it, take your time, continue reading, go through life. I believe with time, if you come back to this video, it will make more sense. Thank you very much. Academic Daddy.